Alright guys, welcome to this page of the notes. Now, recall what we're doing is we're looking at solving systems of equations. We've already looked at the first objective, solving a system of equations by graphing the system. What we're doing now is looking at finding algebraic solutions to the systems of equations. And I just want to remind you of one quick thing I mentioned earlier in the notes, and it is this. Let me highlight it for you. Never true. The system of equations is inconsistent. So what happens is if you solve the system and you wind up with a statement that is never true, a statement that's never true, it's a false statement, you're going to have a system that is inconsistent. And if you solve the system of equations, right, and you wind up with a statement that is always true, then the system of equations is consistent and dependent, a statement that is always true. Something like 0 equals 0, or -2 equals -2, versus a false statement, which would be like 0 equals 4, or -1 equals 10. Like, no, that's just not true. So here we go. We're going to go ahead and do a couple more problems together. Let me slide this guy on up, and we will take a look at this system. Now, careful. Yes, 90% of the time we're going to use the method of elimination or multiplication elimination, which we just looked at. But if you're careful and take a look at this system of equations, you'll notice the x has a coefficient of 1. And remember, I told you there are only two situations where substitution might be faster. The first is if you have an equation that has already been solved for a variable, which I don't have. And the second is if you have a variable with a coefficient of +1 or -1. And I do. This guy. So let's go ahead and solve for x. This is a prime example of substitution being a quicker method. So let's do it. X is equal to -5y plus 3. I'm going to go ahead and substitute that guy in for x, and I wind up with 3 times a -5y plus 3, because that's what x is equal to. -2y is equal to a -8. Well, now what I have is an equation that only has y's in it. Simplify, combine like terms, and you are done. -15y plus 9 minus 2y equal to a -8. Combine like terms, -15y minus 2y should be -17. I'm going to subtract the 9 to the other side, and what do you know? You get a -17. -17 divided by -17 means that y is equal to 1. Awesome. Well, now all I need to do to finish this problem off is plug y back into the equation where I'm solving for x. So let's do that. X is equal to -5y plus 3. Plug in the 1. X is equal to a -5y times 1, which means x is equal to -5 plus 3, which means x is equal to a -2. My solution is going to be the ordered pair -2, 1, and my system is consistent and independent. I have a solution, and the equations are separate lines, 1 and -2. Well, y -1, x equals -2. Let's head on over to the next page and try a couple more of these. Again, just watch out for those the perfect candidates for substitution, where substitution could possibly be a slightly faster way of solving the problem than elimination. All right, well, I take a look at it. I don't have any variables with a coefficient of 1, so substitution's out. We're going to be doing elimination. What I want to do here, I definitely don't want to close that, sorry. What I want to do here is take a look and see, do I have any variables with the same coefficient opposite in sign? I don't have any variables with the same coefficient, but I do have a variable d that has opposite signs, -3 and a +5. Good enough. We're going to go with that one. Because they're already opposite in sign, All I have to do is multiply each equation by the other coefficient. Multiply this guy by 5, multiply this guy by 3. I'll have the same coefficient. It'll all drop out. Here we go. Let's take a look at it. 9c minus 3d is equal to a minus 33. We're going to multiply that guy by 5. Then I'm going to have 6c plus 5d equals a negative 8. Multiply that guy by 3. What that's going to do is it's going to give me a negative 15 here, a positive 15 here. When I add the equations together, these will drop out, and we've successfully executed the elimination method. All right, let's see how this goes. 9 times 5 should be, wait, what did I do? Yep, no, I totally agree. 9 times 5 is going to be 45. Minus 15d is equal to negative 33 times the minus 5. I get negative 165. If you plug that into your calculator, I do have a calculator handy here. Negative 165. And then multiply everybody by 3. That's going to give me 18c. A plus 15d. And a minus 24. We add these guys together. These drop out. Add them up. 45c plus 18c should be 63c is equal. Negative 165 minus 24. I get negative 189. Which means that c is equal to negative 189 divided by 63. It looks ugly, but it comes out to be a minus 3. Fantastic. Well, now that I know what C is, all I got to do is go back and pick D again. I can choose either equation. Neither of them look very nice. It looks like I went with this one, so we'll go ahead and do that. Here, let me rope this guy off. A little bit different work. Here we go. 6C. Sorry, am I standing in front of that? I am. I'm standing in front of it. There you go. There's your equation. 6 times a minus 3 plus 5d equal to a negative 8. I'm going to have 5d is equal to a negative 8. That's going to be a minus 18, which I would add to the other side. So I have 5d is equal to 10. D is equal to 2. All right, so what you've got is you have a solution that is at the point C, comma D, right? C comes first, D comes second. So it would be the point negative 3, 2. Negative 3, 2 would be your solution point. That's the point of intersection for these two lines, consistent and independent. Hey, I got one more here. Let's try this one. Again, hopefully what you're trying to do, if you're comfortable with these, is you are working ahead, trying them on your own, and coming back and checking your solutions with me. So if that's the case, welcome back, and let's see how you did on this one. All right, let's take a quick look. I need to figure out if substitution or elimination is going to be faster. None of my equations have been solved for a variable, so no substitution there. I don't have any variables with a coefficient of 1 or negative 1, so substitution's out. Elimination is just going to be faster. Now, the question is, do I need to do a multiplication in elimination? And right away, hopefully I see, I don't. I have a minus 3y and a positive 3y. If I just add these equations together as is, y's drop out. So, let's do that. Add them up. Minus 3y, positive 3y, gone. We've eliminated them. And I got a 4x plus 4x gives me 8x. And a 29 plus 35 should be 64. And divide 64 by 8, it should get x is equal to 8. Awesome. Love the easy ones. Love the easy ones. Well, now all you got to do is pick an equation to plug it back into. Again, I like positive numbers better, so I think I'm probably going to go with this one. Yeah, probably. That seems good. Let's try it. Why not? 4x, it's going to be 4 times an 8. Sorry, I'm standing in front of it. 4 times 8 plus 3y is equal to 35. 4 times 8 is 32, which means I have 3y is equal to a 35. Since 4 times 8 is 32, and it'd be a positive 32, I'd have to subtract it to the other side, so minus 32. That means I have 3y is equal, look at that, 3. And we get y is equal to 1, which means I have an ordered pair of 8, comma 1. That is my solution. My system is consistent and independent, and this was a nice, easy elimination problem where the y already had coefficients that had the same, or already had the same coefficients, opposite in sign. Add the equations together, and it drops out. I got plenty more of these problems on the next page, so head on over to the next page of the notes, and I'll meet you guys there.